Welcome back my dear friends and students. A very good morning, good afternoon and good evening to all of you. And as you know, this is the data analysis and decision making course under the NPTEL MOOC series, and for the total course duration is 30 hours, which is basically 60 lectures, each lecture being for half an hour, and the total week duration is 12 weeks. And this is the 50th lecture, which is means we are ending the 11th week lecture. So, obviously, you would after this you will take the 11th week assignment, and each week, as you know, there are 5 lectures, each being for half an hour. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. Now, we were discussing about this concepts of utility in decisions and why utility considering the distributions were important. Initially, we considered the concepts of utility in the framework that the distribution of the utility function plus the functional form of the utility function were important in order to understand the way you model it, and that whatever the utility was. And our main concern was to basically find out the expected value of the utility, based on which you will take a decision whether you will rank the utilities from the highest to the lowest, or basically rank the utilities from the lowest to highest, considering that you want to find the variance. Now, obviously, the question will come that why variance, because if the utilities are same, then obviously you try to basically find out the utility for which the variance is the least, or else another way can be when you normalize them. How do you normalize them? This I am just mentioning for your own information. I am sure you would have understood by this time, considering that you have already done about 3 to 4 lectures of utility theory. And the reason why you rank them from the lowest to the highest is basically, say for example, you are trying to normalize them. As I said, you are trying to take the ratio of the variance to expected value, so the normalization would be done. So, that means per unit returns what is the variance. So, that you will basically rank them from the lowest to the highest. In the other case, you want to find out the expected value or the returns per unit of variance, then you will find out the ratio of the expected value with the variance and rank them from the highest to the lowest. Later on, we saw that different utilities give different rankings, because that was a perception based on which for decisions, like say for the football match, if you remember, there were different points given for different tournaments and the ranking changed. Then obviously, also the concept of functional form of the utility, whether it is linear, whether it is quadratic, would have an effect how the ranking is done, based on the fact you are trying to find out the expected value. Then we also saw that given the utility to be fixed, if the outcomes are different, they would also give us different answers, because at the end of the day, you remember the expected value of the utility was basically calculated as integration or summation of the utility function, which is UW, into the PDF or the probability of the utility function. So, our probabilities were basically based on outcomes, and the utilities were basically the utility function based on which we are doing the work. And obviously, it will mean that one person would have one certain utility, the other person will have a certain different utility for the same situation, and obviously, the probabilities would also change accordingly. So, generally there are 2 important facts, as I am mentioning again, one is the utility, one is the probability distribution or the outcomes distribution based on the utility function. Then we consider the concept of certainty value being a certain value where the expected value of the certainty value, considering the probability is 1, would be equal to the expected value of the fair gamble. The fair gamble is where the probabilities are half and half, and you basically have the outcomes of W1 and W2 in the wealth perspective, or the units are not important. Based on W1 W2, I find out the utility of UW1 using the functional form of UW1 and using the functional of UW2. Based on, I do the calculation and I find out what is the expected value of that fair gamble. We also considered, I am going through the recap, please bear with me. So, we considered the concept of non-satiation. Non-satiation means that more I give you, more you want. So, obviously, it would mean that the first derivative of the utility function would always positive. And then the point came up, well, that is fine, but how do we basically categorize human beings based on the perception of risk, which may be I am a risk lover, I am a risk indifferent person, I am a risk hater. So, for to analyze that, the best methodology which I think would be best for you to understand is to consider how the graph for the utility is increasing. So, if it is increasing at an increasing rate, or is it increasing at a constant rate, or is it increasing at a decreasing rate. If it is increasing at an increasing rate, obviously that would mean the second derivative is positive. It is increasing at a constant rate, it will mean the second derivative is 0, and if it is increasing at a decreasing rate, it will mean the second derivative is negative. Now, based on that, we later on proceeded to find out that what if we want to find out the actual characteristics of the utility function, is it possible? The answer was yes. We used the concept of absolute risk aversion property and relative risk aversion property. Absolute risk aversion property and the relative risk aversion property was basically in the absolute sense how we love or hate or are indifferent to risk. In the relative risk aversion property, also in the relative sense, we try to analyze how we love risk, how we are indifferent to risk, how we hate risk. Then based on R, A and R, which is absolute risk aversion property and relative risk aversion property, we found out the concept of what is A prime and R prime, which is the first derivative of A and R with respect to W. W is the wealth. And then we considered the 4 different type of utility functions. Utility functions was quadratic, utility functions was logarithmic, utility functions was exponential, and utility function was power utility. Then based on the mathematical formulation, we first found out the first derivative, found out the second derivative, used the first derivative and second derivative to find out A and R. Then again we differentiated A with respect to W and R with respect to W and found out A prime and R prime. Now, as we found out A prime and R prime, based on that we can basically find out what is the characteristics of the utility function, whether it has positive absolute risk aversion property or whether it has 0 risk relative risk aversion property, which means that A prime can be greater than 0, can be equal to 0, can be less than 0. Similarly, R prime can be greater than 0, equal to 0 and less than 0. So, based on any of the categories, we can basically club these 4 different type of utility functions into one of the characteristics based on which we can say qualitatively. Then we basically took the simple example of a thought out experiment using Excel sheet, and I am please request all of you to please basically take out your time and spend about 5 to 6 minutes in trying to basically mark those values. So, those arbitrary values which I have taken, you can do that also, or you can change the values accordingly what you think is more easy for you to draw, because trying to understand the diagram would be important. You basically plotted, you took some arbitrary values of W based on the utility function, which was quadratic, which was exponential, which was logarithmic and which was power. We found out the value of that utility function U. Next, which is the second and the third and the fourth column, which was basically omitted, we should find out U prime and U double prime. Based on once U prime and U double prime are found out, you will basically find out A, then A prime, next R and R prime. So, when A prime and R prime are found out, check the values, what is the general functional form of those, and check what is the derivations which you have got based on the fact that the utility function is given, those 4 utility functions. Based on this, we are able to find out A prime and R prime using the mathematical formula. So, be rest assured, the way I have basically analyzed this problem in the Excel sheet using a very simple hypothetical example, the answers which you will get using the mathematical formula and using the Excel sheet simple trying to basically draw the graphs in the Excel sheet would give you the same concept, they would be double verified. Then we considered that in case we have the utility function which is quadratic, then there is a one-to-one correspondence with the quadratic utility function and normality of returns. So, it means that if utility function is a quadratic, then returns would be normal and vice versa. So, this would be an if and only if condition. Then we showed that considering the investments, if we basically rank this investment based on the maximization of the expected value of the utility, and same if we consider that we have the returns are normal and basically try to find out the probability of the normality value greater or less than some stipulated value, and then we use the standard normal tables. Based on that, when we find out, we found out that the results which we get from the case of, for the case of the utilization of the values which we have done for the case of the utility function, they would basically match. So, when I am saying they would match, yeah. So, the values which you got from the utility function using the mathematical formulation, the values which you used using the Excel sheet, they would definitely match, and then we will basically try to find out that the utility function, as I was mentioning for the normality one and for the quadratic utility function and the normality of the returns, they would match, because when we rank the investment based on the quadratic utility function and then we separately rank them using normality returns. Normality returns was basically for the case when we normalize the returns to normal case, that is standard normal, and found out the probability less than or equal to or greater than equal to a stipulated value, and we found the ranking remains the same. So, there is no change. Then we consider the different axioms of probability. So, that means the ranking which we do, that A is greater than B and B is greater than C, then obviously be rest assured the ranking which we do between A and C would also basically give us the same picture, that is A is greater than B and B is greater than C. Then later on we also considered that if utility function is generally not given, how we are able to find out what type of utility function you are. So, for that also we took again a very simple example, and this is the third time example is explaining that. So, please try to understand. I am sure you would have, but if it is, there is no harm if I repeat it. So, along the x axis I basically draw the values of W, and I take two arbitrary values of A and B, and for a fair gamble the probabilities are half and half, and if it is a half and half and the utility function is basically linear in the sense that u of A is A and u of B is B, which means the utility function u w is W, then the expected value of that fair gamble would be A plus B by 2. Then also we drew the 45 degrees line. Based on the 45 degrees line, we are able to find out the certainty value, and then if the certainty value falls along the on the 45 degrees line, then be rest assured that the marginal rates of the utility function, that is derivative, first derivative of the utility functions would be positive, but the second derivative of the utility function would be 0. That means, constant relative and constant absolute relative risk aversion property would hold. And in case the values of the values which you plot, I am not drawing it, but I am trying to explain, I am sure you will have understood what the diagram. So, the values of the plots based on when the expected value of the utility and the certainty values are below the 45 degrees line or above the 45 degrees line, you will basically have the concept that of double derivative being greater than 0, and the second case the double derivative being less than equal to 0. So, based on that you can find out whether your risk aversion property is true or your risk loving property is true. Then using the concept of certainty value, we found out that if the utility function is known beforehand in the functional form, but the parameters are not known, you can basically also use the certainty value to find out how the parameters of the utility functions could be derived. Later on, then we consider that apart from the expected value, what are the other different type of metrics or other different type of measures or different type of basically simple concept we can use to rank the decisions. We found out that there was a geometric mean method, and geometric mean method you find out basically the probabilities are given, and then you find out the geometric mean, so that you rank them from the maximum to the minimum. Later on we saw that we can also use the safety first principle, and the concept that the probability of the return RP is less than equal to RL. RL is a fixed value that you basically I try to decrease that overall coverage area between RP and RL. That is one method. Another method can be basically I try to push RL more onto the sides, onto the right, so that the overall return of the so called decisions, average decisions would be definitely on an increased scale. And the third method was basically to push the average of that the return of the decision, which is RP bar, onto the right such that the overall distribution shifts onto the right with a higher returns for each and every corresponding values of RP. Then in the fag end of the class for the 49th lecture, I consider the Chebyshev's inequality. Now, the reason why I went a little bit slow is that we will try to utilize that these decision concepts are very important, and we will try to utilize that in some of the problems for the regression models, and later on when we do the concept of different type of other multivariate statistical methods, and also this concept of utility theory would be repeated again when we do the DADM2 course, which is basically to do with different type of multi criteria decision making, where many of the methods are non-parametric in nature, and how we utilize the concept of utility or the Pareto optimality frontiers in order to understand the different type of techniques which we use from the operational point of view, considering the non-parametric functional form are true, would be utilized. I will definitely come into all these concepts later on, but I thought I will just mention it very briefly. So, consider the concept of this utility analysis from the point of view of Chebyshev's inequality. So, what we are interested is in the Chebyshev's inequality is the probability that RP is basically RP considers a random variable, and RP bar is basically the expected value, and similarly sigma suffix p or sigma p is the standard deviation. So, what we are interested is, if this is the distribution, let me draw the normal distribution. So, our main task is that technically we know, I am considering x only, x is the random variable, is less than equal to sum x. So, consider this sum x for the time being is this. So, my main idea is I want to find out this. So, this is the expected value, and standard deviation is SD is less than equal to x minus E by SD. So, this E value or the expected value which we have is actually this, and the value of standard deviation which we have is basically sigma p. So, trying to find out the expected value of the area using the value of Chebyshev's inequality basically gives us a bound. So, this is the bound which I am talking about. I will try to utilize a different color. So, this is the bound based on which we can say the probability of the standardized probability. So, this is the standard probability. I am not going to highlight it, I am just circulating it virtually. So, this standardized value which is z is greater than equal to some k value, k is a constant, would be less than equal to 1 by k square. That means, I know the bounds based on which I will basically do the calculations. So, once I considering so this is what is going to come. So, the part we should, so this which I consider, I think I should use a different color. So, it is easy for all of us to understand. So, this part which I use is exactly this, and the part which I use here is exactly which I found out here. So, in this case x is basically RL, which is the risk free interest rate, which is generally considered what portfolio investment. So, on definitely, so this can be considered as k. So, 1 by k square would be equal to sigma square p, which is basically the standard deviation square or the variance of the set of all values which are there for the portfolio, divided by, this is basically a sort of normalized norm, where I find out the ratio of the sigma square divided by RL minus RP square. RL minus RP square, I basically remember RP bar is fixed, RL is fixed. So, square of that is a fixed value, while sigma square depending on how the overall spread of the total distribution is, you can basically calculate sigma p square and then do the calculations accordingly. So, basically this value I will highlight using the yellow color. So, this will give me basically the bounds based on which I can utilize Chebyshev inequality to find out the bounds in the decision case. Now, coming back to this again discussion, the right hand side of the inequality is exactly equal to the decision process number 1 under the safety first principle, when you are trying to basically minimize the area difference between R P and R L, considering R P is on the left hand side from my side. So, obviously, it will be left hand side, if you are looking from there, it will be right hand side from my side. Under the phase safety principle we have considered. So, basically what we did was, this was the actually this is the first line. So, once I normalize them, R P minus R P bar divided by sigma p, which is the left hand side here, which I will highlight using a different color, and the right hand side is R L minus R P bar divided by sigma p. So, obviously, this would be the right hand side. So, that we know is basically equal to the ratio, less than equal to the ratio sigma square divided by R L minus R P square, which is what we found out, and this is exactly what we intended to prove using the Chebyshev's inequality as well using the safety first principle. So, which means that trying to minimize the area between R P and R L, considering R P on the left hand side also gives out the same rule or the same concept using the Chebyshev's inequality. So, whichever you use, you will get the same answer as such. So, Chebyshev's inequality basically gives us a bound, maximum value or minimum value, whichever you look at it, and that is what we get from the calculations in the safety first principle, the first criteria. For the second criteria, what we need to do is that we have you have to find out the maximum of maximum value of R L. So, we will basically push R L more onto the right. So, I take the average value, not the average value, and basically. So, this is the distribution, this is the average value, and I consider R L as here. So, what I am trying to do is that I am trying to basically push R L to more to the right, such that the actual probabilities of coverages of R P less than R L, obviously that you will still try to basically minimize in the long run, but if you try to basically put R L onto the right, the overall so called average value of the returns on a random scale would definitely be much higher, in case if R L is onto the left. R L is basically the minimum threshold. So, obviously, minimum threshold also increases, obviously, we will try to push the overall distribution onto the right from my side. And we will always consider such that the probability R P minus R L, which is less than alpha. So, that would be true. So, let me highlight. So, this is we want to put. So, this always remains fixed such that this is less than or equal to alpha. So, if R L is moving, it pulls along the green line, which is if sorry my mistake, I should basically erase this. So, this is consider R P, which is on the left hand side. So, I am trying to basically maximize R P such that the area probability is reduced. So, consider I am considering an orbit value of R P, it can be anything, but technically if I consider the whole area, it should be this. So, this is alpha. So, I need basically keep fixed alpha at this level and try to basically pull R L onto the right hand side, which means, and obviously keep fixed in the sense that I keep it less than or equal to alpha. So, it can be alpha 1, alpha 2, alpha 3, where alpha 1, alpha 2, alpha 3 are less than alpha. So, more I push onto the right, the overall area can be decreased, provided the distribution by itself is also moving. So, pulling R L onto the right obviously would mean that the value of the distribution as such as a whole body will move on to the right. So, we are given alpha, which can be say for example 0.05 or 0.45, whatever it is, and based on that, once we convert that into the standard normal case, it becomes, so this equation which we have here exactly becomes the standard normal case as this, and you can solve it. So, you want to maximize RL based on a constraint. The constraint is basically a simple stochastic constraint, but we know that stochastic constraint considering normality is there, it can be easily done through simple reliability optimization or simple optimization. So, it is not a part and parcel of this course, I am just mentioning. So, in this case you have the utility analysis for the safety first principle. So, alpha is basically on to the left 0.05. So, it could have been on this side also, the total area could have been 0.045, 0.4, 0.45, so on and so forth. So, it depends on how you basically be able to manage the problem. Now, considering that you are basically converting that into probability for the normalized case. So, what we will do is, so if you consider the probability of x greater than less than x, which is probability x minus x bar, or let me put it as, so let me change the values accordingly. So, the E divided by sigma less than equal to x minus E by sigma. So, this is less equal to alpha. So, once we take this term, remember, and expand it. So, obviously, it will be some time number of times left or right of the sigma value. So, if you put it here, so you will basically, so this x and E would be considered in such a way. So, this x is basically R L, E is R P. So, I basically, and sigma is sigma p. So, how many times it is on to the right or the left would be dictated by this equation. So, just make a one-to-one correspondence here. On the right hand side, this is the right hand side of the normalized probability. So, change the fixed rate of RL accordingly. So, we can change it and find out different values of RP, and based on that you can plot it and do the calculations accordingly. So, this is how the values would, if you plot it on a risk return framework and the decision framework. So, your actual value of P star is the best optimal portfolio, but what you are doing is trying to shift it till it is orthogonal to the green line, and we will take that point which will give us the best return. The third criteria is criteria of trying to basically maximize RP, which is the average, trying to push the average value onto the right, such that the value of the probability RP less than, again the same thing, RP less than equal to RL is alpha. So, what we are trying to do is, this is the distribution, this is R, I will draw R this value of, so this is average value which is RP bar, and this is just for information I am giving, this is RL. So, technically this is the area which is alpha, this is the second term, remember here I am not going to highlight it, I am just hovering my electronic pen. So, what you are trying to do is push the average value onto the right. So, as the average value moves on the right, or the whole distribution moves. So, obviously, if it is equal to alpha less than alpha, obviously it can be made less than alpha. So, the criteria of trying to push the values, average values onto right would basically give you higher returns. Thus, with the constraints you can find out, again use the same concept, convert into standard normal, replace that RL x by RL and RP as the expected value, and sigma p remains as sigma p, you can do it and then find out. So, this z is basically the number of times it is higher than the values. So, z is the standard normal values which you have from the table. So, if you basically do the values of RL, now in the initial case you saw that I was pushing it parallelly. Now, consider RL is fixed. So, what you do is that rotate anti-clockwise, the moment it leaves that boundary, it is tangent, you get the best optimum solution based on which the decision can be taken. With this I will close the 50th lecture, which is the completes our 10 weeks, and continue discussing, use this concept in the regression model and so on and so forth, and then again come back to the multivariate statistical methods in a simple way. I did get some feedbacks about the factor analysis and principal component analysis, though are a little bit more theoretical. I will take that in, definitely take that into consideration. Hence, based on that we have consciously taken a decision that use utility in a very simple sense, and for the regression models also we will just give the problems and then come back to the simple analysis of how the problem is done. So, rather than doing the theory and then the problem, we will basically do the problems and then come back to the theory if at all required. So, we will keep it as simple as possible, and with I thought that I did mention very fleetingly about DADM 2 also. I will give a brief background of DADM 2 at the last lecture of DADM 1, such that you can understand, if you give us a very frank feedback that how DADM 1 went. So, we can basically fine tune from our end the good points, and also basically try to reduce the overall effects of some of the teaching methodology which you may have found a little bit difficult. We will take that into consideration in all the seriousness, and we will expect more of your feedbacks more in the forum, and any questions you have, you are most welcome to ask there, and we will take care of them in the full earnestness. Have a nice day and thank you very much.